All right, we're just going to get started here. This is Red and Blue Ping Pong. I'm Anton, this is Lee. So in this talk, we're going to go over who we are, and then we're going to just briefly talk about Windows for attacking and Windows for defending, and then we're going to get into the meaty part, the demo, and then just go over some worthwhile mentions.
So we didn't really figure out who's who.
Yeah, I kind of got the Will Ferrell lookalike vibe going.
That's true, yeah. Well, hi, everyone. Thank you so much for having us here. It's a real honor to be able to present for you guys. Thank you to all the speakers before. My name is Lee Kagan. I'm from Red Black Security here in Toronto. I go by @InvokeThreatGuy on the Twitters. And I kind of spend my time focusing on adversary systems, intrusion sets, that kind of stuff, and really focusing in mainly on Windows Enterprises, Active Directory, Windows things, mainly. And, well, you introduce yourself, man.
Sure. I'm Anton. I work at Equitable Life Insurance in Waterloo. My Twitter handle is Anton Loves DNB. If I knew that I would be announcing my Twitter handle like this to so many people, I would have picked a better Twitter handle. And I'm just a security generalist focusing on the defensive end of things.
So what we're going to do is kind of walk you guys through something called living off the land in terms of Windows attack and defense. Living off the land was really a term that was coined, I think, a few years ago. I really hope I'm quoting this right, by Matthew Graeber and Chris Campbell. This idea of, Windows environments tend to provide you all the stuff you could possibly want for attacking and for defending. And this idea of just staying native, dropping the kit, dropping the big Kali Linux when you don't really need it, and just using what's there to your advantage. So, like I said, Microsoft really provides in that space, not just for defense, but for attackers. I mean, it gives you everything you could possibly want to weaponize. So this idea of living off the land really it's so beneficial from not just trying to emulate anything specific, but for helping to fly under the radar, helps you learn a little bit more about Windows if you're in the attack space as well as the defense space. And, you've probably heard of things like PowerShell and all that kind of stuff, and we're just really skimming the surface here. But PowerShell on its own, which has been sort of the buzz for a while now, it's great because it allows you to interact with the .Net framework, Win32 API, all this kind of fun stuff. You have WMI, you have SIM, CIM, Windows PowerShell Remoting, Active Directory, as we heard about earlier, which just loves to tell you all about itself. So it's really handy for an attacker. And then you also have this space of the trusted things. So if anyone's been following the work of people like Subt, Casey Smith, or Enigma OX3, who is Matt Nilsson, he's Mr. Bypass UAC and all this kind of fun stuff. These trusted things is really what's so great to help abuse, because if the trust is there, we get to hijack it and use it for evil stuff. And then finally, another great thing that really helps with this idea of living off the land is the MITRE ATT&CK framework. If you haven't been exposed to it yet, I highly suggest you go out and take a look at it. It's absolutely fantastic. It's early in its inception, but it's so handy, especially for the defense people too, to really understand this categorical tradecraft perspective of attackers. So we're also going to try and go really quick to get through this stuff and get over to the demo, which is like 99% not going to work. But while we're at it, what I wanted to show was just some super basic examples of things you can do with PowerShell and WMI and commandlets. It doesn't really get any more basic than this. So what you're looking at here is everything done inside of a PowerShell prompt, calling WMI via PowerShell commandlets. So at the top line there, I'm asking for the installed antivirus. Not a big deal, right? Might be an admin want to do the same thing. So we say get WMI object. The class I want you to ask is the namespace of the root security security center 2 class antivirus product. Just show me the name, right? Not a big deal. Next one down, I'm doing the same thing for the operating system, right? Tell me the OS, I'd like the build number, so on and so forth. And then finally, show me the CPU information. Why does this matter? How is this an attack? It's not. These are baked in, right? They're there because they wanted people to use them, specifically like an admin. Something I like to say every now and then is what's the difference between an administrator and attacker is intention. That's all it is, right? If the commands are there, you might be using because I want to know what the OS version is. I might be using it because I'm trying to target a specific OS version. So you put these three things together, they kind of sing to me as the beginner steps of like a checker script you might have in your malware, right? That last one is checking for cores. It's like a really poor person's version of an anti-VM check. You know, if the computer has 1 or 2 cores, chances are it's not a real computer. But this stuff's baked in, right? It's all there. And again, just skimming the surface, you can ask for so much information from PowerShell and interacting with it. To expand that a little bit more, here's using PowerShell to interact with the .NET framework. And basically all I'm doing is saying, I would like to know about this domain. So if you've never seen interaction with the .NET framework before, it's the dot, system dot, directory services dot, Active Directory dot, so on and so forth. But that simple one-liner gives you a wealth of information. We got the forest we're in, the domain controllers. If there's more than one, they would be in that curly bracer. If there's child domains, the forest function level. We get the PDC, the primary domain controller, the one you probably want to go after. So you get this awesome amount of information just off this one baked-in command. And then the one at the bottom there is using something called ADSI. It's what's called a type accelerator. And in this, it's just a fancy way of saying, show me all the organizational units. I'm really only interested in the canonical name of them. And it spits this all out for you at the end, called Surface Lab. I'm on my barely performing Surface Pro here. So we got Surface Lab Desktop, Surface Lab Standard Users, so on and so forth. And then finally, just another basic example is something called PowerShell Remoting, which is done over WinRM, which uses SOAP. And it's so awesome, not only as an administrative way of doing remote work, but also for an attacker. And one of the reasons I love it is if you see at the top, I'm desktop 1, I start a new PS session on the domain controller, and then I enter that session. Reminds me a lot of Meterpreter, which is something I kind of always loved about WinRM, like session 1 spawned. Go into session 1 and do some stuff, and then spawn session 4, and go into that session and do some funky stuff. It also has some, I don't want to say anti-forensics, but it has some headaches WinRM can cause for blue teams. So what I just wanted to show here was super basic examples of things that exist on a Windows system that, if weaponized, give you a lot of leverage. Right? They give you a lot of opportunity to move around and query the local system, query remote systems, interact with other stuff, the domain controllers, so on and so forth. And I think Anton's going to take over from here and show far more interesting things.
Thank you. Right. So just like Windows provides a lot of things for attacking, it also provides a lot of things for defending as well. The cat's not included with Windows, but it's there. So some of the things that Windows provides, Sysmon, device guard, various GPOs, newer operating systems themselves are inherently more secure. ATA and ATP are also big ones, and you as well, because you know your network hopefully better than the attacker, and you know where your weak spots are. So let's just walk through some of these in action. This guy, Lee, mentioned sub-T, Casey Smith. So he basically took MaybeCats and made it into a JScript format. So the screenshot here is showing MaybeCats being run through cscript.exe. So not your standard MaybeCats.exe at all. So it's pretty stealthy. On the right-hand side, you see a sysmon rule catching that LSAS was accessed by cscript. So that should throw up huge red flags for you. In a similar vein, this is MaybeCat's same version, just run with PowerShell instead. And like the same slide, sysmon happily shows you here that PowerShell accessed the LSAS process. So that, again, big red flag. The granddaddy of defenses, device guard. Device guard is magical for defending Windows systems. The top screenshot there is showing all kinds of shenanigans going on. You have calc being injected into the running putty process. You have unsigned code, putty.exe, running happily. And at the bottom, this is a system with device guard. So PowerShell is now running in constrained language mode, so no more putty.exe. It's not signed, not allowed to run. You can't call the APIs required to do that anymore. And on the little screenshot there with Twitter, I don't know if you can read that, but that's basically Matt Graber dropping expert knowledge as usual, saying that you can either keep writing sysmon rules to detect this kind of stuff, or you can just implement device guard. And yeah, one last thing before we get into the actual demo. This is a GPO that Jessica Payne always tweets about. And this is doing two things. One, it's preventing local accounts from performing a type 3 network login. So if you have a bunch of systems and the admin password, the local admin password is the same for all of them, this will prevent lateral movement across those systems. So if the local account can only be used locally. It's also preventing domain admins from authenticating to lower trusted systems. So a domain admin can't log into a server that's not a domain controller or a workstation. So their credentials, their tickets, their hashes, they don't get stored there. And the screenshot there is just showing CrackMap exec running with just two systems there. The username and password is the same, and you can see the status logon type not allowed. So big nope. And yeah, we'll get into the demo.
Thanks. So what we're about to show you guys, and again, is it's a super basic setup. And we really wanted to keep this very simple for you. So it's just going to be a Windows 10 enterprise desktop. We're sort of doing the assume breach thing. Somebody dropped something nasty on the machine. And I'm going to run through about, I don't know, like 7 or 8 different attacks. I'm going to execute a payload via PowerShell in memory. We'll do some process injection, drop MaybeCats. Actually, the application whitelist bypass isn't needed because we don't have it enforced. Persist into registry, persist via WMI, some PowerShell encoded commands, malware that has stolen the signature from a trusted binary and applied it to itself, as well as unmanaged PowerShell in case someone has removed the ability for PowerShell to run. You can put it back on the system. And then a little script that Anton put together is going to catch all of this stuff. And I think one of the ironies to this is he just wrote a basic PowerShell script, and I'm going to be calling all this stuff down through Cobalt Strike, which is $4,000, and he's catching it with a script. And so it's really cool. The stuff that you can do with Windows, it's already there for you. I think the only additive is Sysmon. That's it. And with that being, he's going to catch injected threads, look for parent-child relationships that are sort of suspect command line arguments, authenticode mismatches, things, PowerShell running anything encoded, stuff that's trying to touch LSAS, unmanaged PowerShell, basically the blue equivalent to all the different attacks I'm about to demonstrate for you guys. And with that, let's dig right into it. Okay, everyone pray for me right now.
Pray for Mojo.
Okay. What's up with airline food?
Just out of curiosity, does anyone actually run Sysmon in production? Nice. What about the Vice Guard? Just curious about that too. Awesome.
There we go. Okay.
No. Two different people.
Let's see if copy paste actually works today. Nope. Okay. Meanwhile.
Sure.
Ask questions right now.
Yeah. 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 It definitely does go. Right. Did everyone hear that question? Okay. Yeah. The question was, what do you do with all the data? That's a great question. The good thing about Sysmon is that the configuration is very granular. So I'll show you if the demo works, you'll see a bunch of stuff, and you can see that you can filter out certain noisy things from the Sysmon config.
So you do put it in the SIM or somewhere?
It does go in the SIM. Yep. Yep.
Yay.
Any other questions while we're waiting?
No, we're good, man.
Okay, we're good.
Okay. Space we're going to start with, we just launched a PowerShell command on the... Oh, yeah, that would help. Cool. How do I get rid of that? Just close it down.
Yeah. Just kill
Cool. Okay. Sorry, guys. There we go. So we have this infected machine. That's the red and lightning, if that wasn't obvious. And so it was just PowerShell injected into memory via command line download cradle. Thank you, sir. And first couple things we're going to do is, I think we're going to start with the process injection. So basically what I'm going to do is look at running processes, which I'm going to do like this. Sorry, the font is so small on here. Oh, right, sleep time. Yeah. So that you guys don't have to wait 60 seconds between every command. Okay, so 3 should be good. We're going to inject another agent into a process that probably would have no business launching a command prompt, which is going to be OneDrive, just for the hell of it. Let's get those guys back. How are we doing? Oh, cool. We can all just hang here for like 35 seconds. So first I'm going to inject in this new process, spawn a new agent, use that process of being inside of OneDrive.exe to open a command prompt, and that's going to trigger a rule that we're going to catch when this thing checks in. And then from there, I'm just going to do all that stuff you saw on the slide of different attacks. Isn't dead air awesome?
There are various system configurations I've seen on the internet. Is there one you like in particular that?
Swift on securities. Awesome. Really, really good. It keeps getting updated too with nice rules. Really, really good. There's another one from I want to say like DFIR Hunter or something like that. I can't really remember.
Just make sure you test it. Because when I ran it, it didn't find certain things that were in the config, because I think she did it for her environment. So certain registry keys are not set exactly the way they would be on all systems. So test it first.
Okay, so there we go. New shell. This is living inside of OneDrive. So I'm just going to say, through a shell prompt, run command.exe. That's going to trigger one of our rules that we're going to catch. And then we'll go back to this guy. And, oh no, I didn't start inside of the right directory. Yep. Oh no, we're good. Okay. CD attacks.
Do you see much overhead from Sysline?
No.
Okay, so
Just to convince him.
I don't. It's
You
a
got to
little-
try this one. It's the best. Yeah.
little blurry there, guys. I'm just going to run through these 4 things here. First, I'm going to launch this badsig.exe. This is a piece of malware, and it's been signed with the Microsoft signing certificate from TCP view from the sysinternals kit. And that'll spawn another shell, which is horrible tradecraft. And then after that, we're going to use cscript to launch our MaybeCat's JavaScript version. We'll do that. Sorry? Oh, yeah. Input error. Oh, JZ. That's not right. JS. There we go. And then finally, this nps.exe from Ben Turner is not PowerShell. Basically, PowerShell's been removed. It's got all the functionality, the automation DLL to be put back in. Cats.js, really? What did I type? Ugh. You guys are far sharper than me. By the way, don't have like 4 beers before a talk. just FYI, And then finally, not PowerShell, and it's going to allow me to use basic PowerShell commandlets with it. So I'm just going to say get process. And I'm also not waiting for the output from all of this stuff, just to breeze through it really quickly because I know we're running short. And then finally, let's just do in-memory MaybeCats like that. What else are we forgetting, man?
The run key?
Oh, the run key, yeah. Okay. So I'm just going to drop a couple forms of persistence here. BSidesTO commands. There we go. This way I don't have to type all this out. Perfect. Okay, so this is going to use PowerShell to add a registry key. And then finally, WMI persistence using what's called WMI permanent event subscriptions, which is kind of a cool technique. Shell, PowerShell, EP, bypass, let's do nup, and WMI persist.ps1. Cool thing that we just did there is that registry key is going to launch Notepad whenever the user logs back in, and the WMI persistence is going to watch for Notepad as a process being created, and anytime it sees that process, it'll launch Calculator, just simulating the bad thing, basically. And I think that's all of the attacks. Now let's see if we can catch these suckers. Do you want me to just set it up first and pass it over to you? Sure. Cool. How we doing on time? Good timing. Jesus. So Stranger Things 2 was good. Sorry, it's a little laggy, folks. I apologize. Yes, we know. Thank you. Invoke BSidesTO. Respond. There we go. Do you want to maybe start walking through the script? Just when I say yep.
Yeah, so I'll just start walking you guys through the script of what it's actually looking for. Basically, the script is running, first it's running a PowerShell script called Get Injected Thread. It was written by Jared Atkinson, and what it does is it searches processes, and it goes into those processes in memory and sees which one had something injected to it. So when Lee did his inject into OneDrive, that script will hopefully find that. The rest of the script basically just combs through sysmon logs and finds odd stuff, like CMD running from OneDrive. That shouldn't happen. You have PowerShell DLLs loaded by something that's not PowerShell. That shouldn't happen either. You have C script accessing your LSAS. Again, shouldn't happen. Okay, let's run this sucker. Let's hope this works.
That's me. I butchered the banner.
It's supposed to be windy. So that's the first step it's doing, is just grabbing the injected threads that I just talked about. Now it's looking for suspect process relationships and breaking.
That's not good.
No events are found.
The gods. That is super weird.
Yeah.
Let's take a look at the report.
We might still have an old report that we can show you guys.
What am I looking for? Desktop. Oh, we're almost at the end of the time, so that works. Wow, that's super weird.
I found some stuff.
Yeah. Okay, let me try this one. I'm just going to run the script one more time, guys. One sec.
You gotta kill the chicken first before you run it again.
Always.
To be clear, no chickens were harmed in making them.
None were harmed, guys. None. What was the actual error? Oh, maybe. That could be why. Yeah. Nope. We want modules. Get injected thread, and then we want get when event. I thought I did, but maybe I didn't. And then don't be shitty. Well, it does work sometimes, and then it catches all this stuff.
The idea is to have this stuff in your sim. Obviously, you're not going to be doing this for like thousands of systems, but
This one actually shows some of the functions. Okay, that's looking like that. Fuck off.
Push that button one more time, you hit the definition.
Totally. It'll work this time. All right, well, I'm really sorry about that, guys. It worked downstairs.
That was how many years ago?
4. Well, let's see what did actually spit out. Am I even inside the fucking VM? No. Well, when it does work, it does this. Well, at least it caught the injected threads.
right. So this is kind of the stuff it would have caught, but sorry, it didn't work.
But yeah, anyway, sorry. We're going to wrap this up now. Basically, this is not production ready. If you haven't figured that part out yet, but it works when we do it. But it's something we're going to put on GitHub and tweak, obviously, and get it to something we can share. The idea really behind this is like this is not something that's supposed to solve your problems. It's just showing how with get win event data, get injected threads, you can go look at the Windows event logs from Sysmon and pull out all of this stuff, WMI activity, beaconing, all that kind of stuff. It does work, trust me. But yeah, sorry guys, and.
If you build a video of a working copy, we'll include that with the slides.
We'll do that. Actually, I think he has one.
We do have one,
Yeah. Cool. Thanks, guys. Sorry about that.
Thank you.
Appreciate your time. Thank you.